Alright, here we are to finish up our lesson on conditional statements, part 2. I think that would be lesson 2.04. Don't forget to give me your course and section number with all communication. And our objectives in lesson 2.04 are to create and interpret truth tables for conditional statements and use the law of contrapositives. And I will tell you that you will have to create a truth table on the Unit 2 Part 2 test, so be sure to study it and make sure you understand it. Okay, some new terms that we're going to be looking at in this lesson are the law of contrapositives. That's a conditional statement is true if and only if its contrapositive is true. Truth functionally equivalent is a characteristic describing a pair of statements that have identical truth tables. A truth table is a tabular summary of the truth values for a compound or conditional statement. Each truth value is either true or false. And a truth value, the truth status of a conditional statement. The truth value is either true or false. Now, conditional statements in symbolic form. We have to learn this in order to complete the truth tables. Okay? Mathematicians generally use P for the hypothesis and Q for the conclusion. So I gave you my skunk conditional statement. If I am a skunk, then I stink. You see, I've named the hypothesis P. I've named the conclusion Q. There's a reason we do this, is because when you're filling out a truth table, you don't want to have to write out the hypothesis and the conclusion a whole lot of times. So this says if P, then Q, or P, then Q. Alright, the symbol, this little arrow symbol means implies, but a lot of time we use the word then. We'll say P then Q, or we'll say P implies Q. Either way is accurate. So for your truth table, it says anytime you are given a conditional statement in which the hypothesis and conclusion are both true, the conditional statement itself is true. So this little picture says a true hypothesis plus a true conclusion equals a true conditional statement. So when you make a judgment about whether a statement is true or false, you're going to assign it a truth value. Now to get into the truth table part. Truth tables are organized. By the way, let me start this over. Truth tables are an organized way to look at the possible truth values of an expression. Your T is going to mean true and F means false. And for this truth table, for the example, we're going to use if I am a skunk, then I stink. But what I want you to understand is when you're doing a truth table for a conditional statement, the truth tables will always look the same for all conditional statements. Okay? They will always look the same for your converse statements. They will always look the same for your inverse statements. They will always look the same for your contrapositive statements. I'm just putting my example, my skunk example up here to help you understand why the table works. So here's what we got. If P, then Q. So you're always going to set up a column for P. You're going to set up a column for Q, and in these columns is where we're going to put our T's and F's. Then we'll set up a column for our P implies Q. So first we're going to say, well, if the hypothesis is true and the conclusion is true, then the conditional statement is true. Remember, I did a slide on that just a while ago. So if I am a skunk is true, and then I stink is true, then I must be a skunk and I must be stinky. That's going to be a true conditional statement. Okay? Now look at this next one. My hypothesis is true, but my conclusion is false, then the whole statement's going to be false. It says whenever a true hypothesis leads to a false conclusion, the entire conditional statement is considered false. Well, I am a skunk is true, I stink is false, then the whole statement is false. Think about it. If you don't stink, then you're probably not a skunk. Okay? Now then, when the hypothesis is false, the entire conditional is true. So here I got a false hypothesis. Oh, I'm not a skunk. I've got a true conclusion, and I stink. Then it's true. Well, what if I'm a human and I haven't taken a bath for a couple of weeks? I'm gonna stink. So hopefully that explains why it's still true. Now if I have a false hypothesis and a false conclusion, then my statement is going to be true. Now that seems kind of crazy, but think of it, two negatives make a false, okay? Of course the whole negative positive doesn't work for all of them, it just works for that one and the first one. Now the conditional only states what happens if you are a skunk, okay? So if I'm not a skunk, then I don't stink. That right there means I could be a human and I took a bath this morning, then it can be true. Okay? Now remember, no matter what your statement is, remember I just used the skunk as an example, no matter what your statement is, your conditional truth table will always look like this. Always. And notice the only time that a conditional is false is when the hypothesis is true and the conclusion is false. Now let's do one for a converse. Remember, your converse switches the hypothesis and the conclusion. Okay? And again, I'm using the skunk example, but this truth table is what every inverse truth table will look like. I mean converse. You're still going to make a column for P, you're going to make a column for Q, you're going to make a column for Q implies P. Some students find it easier to switch out the P and Q columns. That's fine. I don't have a problem with that. So, if I stink, then I'm a skunk. My I stink is true. I'm a skunk is true. So the whole statement's going to be true. Now, if I don't stink, but I am a skunk, that's going to be true. Okay? Now that's kind of tricky. I don't stink, I am a skunk is going to be true, because remember, it's just saying if I stink, I don't necessarily have to be a skunk. Or if I don't stink, I don't necessarily have to be a skunk. So it's going to be true. Now, I stink, I'm not a skunk. Okay? I could be a human that stinks, so that's going to be false. And then the last one says, I don't stink, I'm not a skunk, and remember that's true because I could be a human that doesn't stink, or I could be a human that does stink. However, it's still going to be true. So the converse reverses the order of the hypothesis and conclusion, and the only way for the converse to be false is when Q is true and P is false. The LMS shows these tables together and it'll help you understand it better. And remember, this is what your converse table will always look like. Okay? Regardless of the example, your converse truth table will always look like this. Let's look at an inverse. And remember, an inverse negates both the hypothesis and the conclusion. And I'm going to read this down at the bottom right quick. It says, we show negating by putting a squiggly line in front of the P or Q. And this will be read as not P or not Q. So remember, when I'm going to negate both the hypothesis and the conclusion. So if I am not a skunk, then I do not stink. So this means if not P, then not Q. When you're doing a negating truth table, you always put the actual P and Q column in your table. Then you're going to add the not P and not Q. And then I'm going to say not P implies not Q. Now look at this. If I am a skunk, I do stink. Those are both true. So that means if I'm not a skunk, it's going to be false. And if I do not stink, it's going to be false too. And remember, if they're both true or if they're both false, it's going to be true. So look here, we've got true for our P, false for our Q, and so that means not P is going to be opposite of P, which is true to F, false. Your not Q is going to be the opposite of Q, goes from false to true. Okay, now remember, if your hypothesis is false and your conclusion is true, your conditional statement's still going to be true. The only reason they put the P and Q columns here is so you'll know what truth value to put in the not P and not Q. When we're deciding on whether the conditional is true or false, we're not looking at P and Q over here. We're only looking at not P and not Q. So remember, if your hypothesis is true and your conclusion is false, your conditional will always be false. And then notice how I've got falses for P and Q, so that means not P and not Q will both be true, which automatically makes the conditional true. So negating P and Q also negates their truth values. The inverse is only false when not P is true and not Q is false. That would be right here. Last one, the contrapositive. If I do not stink, I am not a skunk. So remember, we're going to switch the hypothesis and conclusion, then we're going to negate them. So look here, got my original P and Q column, and also remember the only reason I add the P and Q column is so I know what the truth values will be for not P and not Q. My last column says not Q implies not P. Oh, let me go back. So if P and Q are both true, that means not P and not Q are both false. Well, remember, if your hypothesis is false and your conclusion is false, your conditional is still true. My P is true, my Q is false, so that means not P is false, not Q is true. See, my truth values are just being negated. Remember, if your hypothesis is false and your conclusion is true, it's going to be false. Because I'm not a skunk can be true, but I can still stink. So that's why it's false. Negating the P and Q, my not P is going to be true, my not Q is going to be false. So if not Q is false and not P is true, then my statement's going to be true. And then here's the last one. If both not P and not Q are true, then the statement's true. It says the contrapositive can only be false when not Q is true and not P is false. All other truth values for the contrapositive are true. Now let's talk about the law of contrapositives. Remember how I told you all your conditional statements, originals, well, your truth tables will always look the same. Here's a truth table for the contrapositive. Now, what do you notice about the truth values as shown by the last columns of each truth table? So you're going to be looking at this column compared to this column, and we're comparing the original conditional to the contrapositive. So the last columns of both truth tables are the same. This means that whatever is true for one is true for the other and vice versa. The fact that a conditional statement and its contrapositive are functionally equivalent is known as the law of contrapositives. So on the test, they're going to ask you to explain the law of contrapositives. You're just going to say that their truth values are the same. They're exactly alike. So the converse and inverse of a conditional are also functionally equivalent. So if I look at the last column of a converse, compare it to the inverse, the truth values are the same. So if you prove the inverse is true, you've also proven that the converse is true and vice versa. Let's look at some examples. It says for each statement do the following. Write the conditional and if-then form, the converse, the inverse, the contrapositive, and determine the truth of each statement from parts A through D and the conditions under which any of the four statements is false. So our statement is vertical angles are congruent. Part A says if angles are vertical, then they are congruent. That's written as a conditional if-then form. If angles are vertical, then they are congruent. So part B says write the converse. So that means I'm going to flip these guys. I'm going to say, well, if angles are congruent, then they are vertical. Okay, I'm going to tell you right now, part A is true. Part B is false. Okay, because even if the angles are congruent, they don't have to be vertical. You could have two right angles. You could have two angles that measure 30 degrees and so on. If angles are not vertical, then they are not congruent. And that's true because if you have two angles that aren't vertical, they do not have to be congruent. They can be any size. And that was the inverse, by the way. I apologize for not saying that first. Part D says write the contrapositive. So remember, we're going to take the inverse and flip it. Or rather, we're going to switch the hypothesis and conclusion and negate them. If angles are not congruent, then they are not vertical. Well, that's true also, because if we know if they're not congruent, we definitely know they're not vertical. Part E says determine the truth of each statement from parts A through D and the conditions under which any of the four statements is false. So it says the conditional and the contrapositive are true. The converse and inverse are false. Angles that are not vertical can be congruent, such as right angles. Now then, they didn't show it, but in the key, but they should have done up a truth table for this, and I just noticed it, or I would have done one myself. But if you do a truth table, it's going to help you see how to answer part E. But you know if your conditional is true, which is part A, then you know D is going to be true. Okay? If I looked at part B and I said it's false, then that means C is false. We're going to do the same thing. It says when n is an even number, n plus 1 is an odd number. So the first thing that we're going to have to do here is write it in a conditional if-then form. If n is an even number, then n plus 1 is an odd number. Now we're going to have to flip the hypothesis and the conclusion in part B. We'll say if n plus 1 is an odd number, then n is an even number. Okay, so we're negating. See, we say if n plus 1 is an odd number, and we're not negating, I'm sorry, we're switching. N plus 1 is an odd number. N is an even number. N is an even number. Part C is the inverse, which means we're negating. If n is not an even number, then n plus 1 is not an odd number. And then part D says write the contrapositive. So if n plus 1 is not an odd number, then n is not an even number. See, you got to do a little mental math a little bit here to figure this one out for the truth of each statement. Let's look at A. If n is an even number, then n plus 1 is an odd number. So you got 2 plus 1 is 3. 4, or wait, no. Let me back up. I got my odds and evens mixed up. If n is an even number, which is 2, I add 1, I'm going to get 3. If n is 4, I'm going to add 1 and get 5. If n is 6, I'm going to add 1 and get 7. So it seems pretty certain that part A is true. Well, if part A is true, then D, the contrapositive, is also true. If n plus 1 is not an odd number, then n is not an even number. And the way you'd look at that is that n plus 1 is not an odd number. Okay, so if I took n plus 1 and I got 4, then 4 is not an even number. Okay, so A and D are true. Let's look at B. If n plus 1 is an odd number, then n is an even number. So if I say n plus 1 equals 3, okay, is 3 an even number? No. Wait, no, yes. Sorry about that. Because if I got n plus 1 equals 3, that means n is 2, and 2 is an even number. If I have n plus 1 equals 5, that means n was a 4, and 4 is an even number. So my converse and inverse are also true. There we go. You got to give Ms. Poor a second to unscramble everything in her mind. The conditional, converse, inverse, and contrapositive are true. Okay, this was a really long lesson and we covered a whole lot. And so our summary is going to be 2 pages long. When you have truth tables, the first 2 columns are identical. Doesn't matter if it's conditional, converse, inverse, or contrapositive. The first 2 columns, P and Q, are always the same. And let me go back right quick and show you. I can't go back quick enough. Oh wait, that was good right there. Notice this is TTFF, TFTF, TTFF, TFTF. That's for the conditional and contrapositive. Notice how they're both the same. Now remember that TTFF, TFTF. Look at your, let me go to the next one. Look at your converse and your inverse. TTFF, TFTF, TTFF, TFTF. Those first two columns will always be the same. Okay, the only time you get a false truth value for the entire statement is when a true hypothesis leads to a false conclusion. For the converse and contrapositive, the hypothesis and conclusion are switched. Be sure to read the statements to yourself correctly, putting the Q first and the P second. Once you know when the entire conditional statement is false, the statements must be true for all other situations, including when the hypothesis is false. And remember, the law of contrapositive states that a conditional statement and its contrapositive are functionally equivalent. Their truth values are the same. Now let's look at this one. It says different forms of a conditional statement have different truth values. To determine when a statement is false, remember, the hypothesis for the original statement is P, the hypothesis for the converse is Q, the hypothesis for the inverse is not P, the hypothesis for the contrapositive is not Q. The conditional statement is only false when the hypothesis is true and the conclusion is false. That's a whole lot to remember from one lesson. Now what you should do, view the LMS lesson 2.04 Reasoning Arguments Proof Part 1. I believe that should be conditional statements, not reasoning arguments. Complete the student guide. Read pages 37 through 41. Complete problems 19 through 31 odd, 32 through 33. Contact me if you have any questions before you take the quiz, and then make note of any general questions you may have before you attend CC on Thursday. And I apologize for the length of this video, but we had to get it all covered for lesson 2.04. And thank you for listening.